In this lesson, we're going to take a look at a work done by a force that changes. So if we were to graph how a force changed as you were pulling or pushing on something, we've been looking at a constant force. So it looks like this. So we have force over here and we have distance down here. And so we could say that the work done is force times distance, but the force is the height of this shape. The distance is the length of this shape. And we would say that the work is equal to the area, as long as the force and the motion are always parallel to each other. But we don't always exert forces constantly. So if you've ever stretched a spring or compressed one that goes the other way, you know the farther you pull that thing apart or squish it together, the harder it is. You have to exert more force. And so your force versus distance graph might actually look more like this. Okay? Well, the work equals the area thing still applies. So if you can find the area of this graph, you can still tell how much work was done. It's just that finding the area of that graph might be difficult. You could break this one up into sections and you could say, well, this triangle has some area, this rectangle here in the middle has some area, this triangle has some area, and then this rectangle down here has some area. So if you're presented with an issue where the force isn't constant, that's okay. You graph force versus displacement and you can actually still get the work done. And remember, if you do have something that looks sort of triangular like that, the area of this is half base times height. So you could use the average, really. That means, right? So the height is the minimum to the maximum force. Half of that is the average force. So the work done by the force is half base times height. If it's this triangular, it's basically the work done by the average force.